The backward phase of the row reduction algorithm produces a matrix in what form? Row reduced echelon form or reduced echelon form? No, if you wrote row reduced or just reduced echelon form, they're both acceptable. Yeah. Echelon form by itself is not. Okay. What? No, no.
Do you get half a point if I had reduced and I erased it?
No. Okay, true or false? A pivot is the bottom leftmost zero entry. False. Yeah. Yep. In what form are all the leading entries 1? Reduced echelon form or row reduced echelon form. Nope.
So it's 1 for writing a question, 1 for each point.
Yeah, I'll go over it in a second. Okay, so to give yourself a grade, if you wrote a question on a note card, you get a point. You get a point for each correct question on your quiz, and then you can earn a point back for a wrong question if you took notes on the section. And again, you don't have to hand in the notes or show me the notes, but keep them in case I ever ask to see them. All right, so let's look at today's class. Today we're going to refine and extend the methods we learned last class regarding solving a system of linear equations using a matrix and elementary row operations. You all read about it last night. We're going to add the backwards phase, right? So last class we used the 3 elementary row operations to put a matrix in what we called triangular form. That's also known as echelon form. Okay, so triangular form and echelon form are the same. That is that we made it so that we had zeros underneath the diagonal. In pursuit of that goal, you worked column by column from left to right, using the nth row to eliminate all entries in the nth column below the nth row. Okay. It turns out that what we learned last class, it's sufficient to solve a system because you can then back substitute from there and finish solving, but it's only half of a complete algorithm that's often referred to as Gaussian elimination. After we get the matrix into an echelon form in the forward phase, then we're going to make all of the leading entries 1, right? Called the leading entries, also called pivots. We'll make them all 1. And then we're going to make each leading one the only non-zero entry in its column. So instead of having just zeros below, we're also going to have zeros above. Yeah. Yep. So to obtain a reduced echelon form, start with an echelon form, right? So first, we'll do everything that we did last class, get it to echelon form. Then you work column by column backwards from right to left, starting with the second to last column, using the nth row to eliminate all the entries above it. Okay. All right, so we'll do one together, and then I just have a bunch of practice for you. All right, so first thing we got to do is translate this to a matrix. I've got variables x, y, and z. So my x coefficients are 2, 0, 3. My y coefficients are 0, 1, 6. And my z coefficients are -6 to -2. Constants, -8, 3, -4. Okay, so first we're just going to do exactly what we did last class. We're trying to get this into triangular form. I'm going to work column by column, left to right. 1 and... Oh, sure. Sure, we can do that. Swap row 1 with row 3. Okay, so we get 3, 6, -2, -4, 0, 1, 2, 3, and 2, 0, -6, -8. All right, so yeah, that did put us a step closer to echelon form because now I just have to get 1, 0. All right, so I need to get rid of this 2 that's in the lower left here. So what do I do? I'm going to multiply row 1 by negative 2/3, negative 2/3, and then add it to row 3. Okay, so I'm going to replace row 3 with row 3 plus negative 2/3 row 1. Did you do the swap first, Len?
Well, the ones I swapped row 2 and.
Well, yeah, then it would be you'd have a different second step. Okay. So multiplying row 1 by negative 2/3. Negative 2/3 times 3 is negative 2. Add that to 2, and I get 0. So I get a 0 there. All right, what's negative 2/3 times 6? Negative 4. Negative 4 plus 0 is negative 4. Ah, look at that. Swapping those rows didn't actually help because I ended up introducing another number. Yeah, so that's why we tend to work column by column rather than randomly trying to put in zeros where I want them. But that's okay. We'll just have to get rid of that in a minute. All right, negative 2/3 times negative 2. 4 4/3. 4/3. Oh, and then I have to add that to negative 6. 4/3 plus negative 6. 22/3. Yeah. 22/3, 18/3, and 4/3. All right, negative 2/3 times negative 4 is going to be 8/3. Oh, no, sorry, it's negative 6. Sorry. Negative 18 plus 4 is 14/3. Negative 2/3 times 4 is negative 4 is 8/3. 8/3 plus a negative 24/3 would be negative 16/3. Oh, I hate these fractions. I wish Cooper hadn't made me switch those rows. Okay, so all I changed was row 3. The other 2 rows are going to stay the same. 3, 6, negative 2, negative 4, and 0, 1, 2, 3. Okay, so now move to column 2. So my first goal is all set in that I have zeros underneath row 1. So I move to column 2, and I want to have zeros underneath row 2. So my goal, the thing I'm trying to get rid of now, is that negative 4. That's all I need to get rid of. Yep. So I'm going to take row 3 and replace it with row 3 plus negative 4 row 2. Yes. Yeah. Positive 4.
Could you just scale row 3 real quick?
I could. Do you want me to so I don't have fractions in that row?
Yes. Multiply by 3.
Yeah. Everybody good with that? So we don't have any more fractions to add? Okay. Yes, it should. Yeah, thank you. Okay, so let's do that first. I'm just going to replace row 3. Row 3 becomes 3 times row 3. Zero, negative 12, negative 14, negative 16. 0, 1, 2, 3, 3, 6, negative 2, negative 4. Okay, so now instead of multiplying row 2 by 4, I'm going to have to multiply by 12. So now row 3 is going to become row 3 plus 12 row 2. Okay, so when I multiply row 2 by 12, the 0 stays a 0, add it to 0, it stays 0. 12 times 1 is 12, plus negative 12 is 0. 12 times 2 is 24, minus 14 is 10. 12 times 3 is 36, minus 16 is 20. My other two rows stay the same. 0, 1, 2, 3, 3, 6, negative 2, negative 4. Yeah. All right, so now, now I'm in echelon form, right? This is lower triangular form. I have zeros in the lower left corner. All right, so now, remember that the right-hand column is your constants, right? So now I want to go backwards. I want all my pivots to be 1s before I start working backwards. So I'm going to scale. I'll do it in one step here. I'm going to scale rows 1 and 3 to make my leading entries 1. All right, so row 1 is going to get replaced with 1/3 row 1. And row 3 is going to get replaced with 1/10 row 3. I'm going to jump to a new page. I'm running out of room. Yep. Okay. So that's going to give me 1, 2, negative 2/3, negative 4/3, 0, 1, 2, 3, 0, 0, 1, 2. All right, so now I've got 1s on my diagonal, right? I have all my leading entries are 1. Now I'm going to work right to left, starting with the Z column, right? And I want to get zeros all above my pivot. That 1 is a pivot. I want zeros above it. All right, yeah, so let's work on the 2 that's immediately above it. So I'm going to replace row 2 with row 2 plus, and I'm going to use the 1, right? Part of making the pivots 1 is that it makes it easy to use them to knock out the things you want to be zeros. So what do I multiply 1 by so that I can, yeah, negative 2 row 3. Or you can just subtract. I just always, I have sort of like this algorithm in my head where I write the row I'm changing becomes the row itself plus a multiple of another row. So like I just always immediately write that plus down and then I decide what the multiple is. All right, so this becomes row 1 stays the same. Row 2 changes, so I'm going to do negative 2 row 3 plus row 2. That's going to stay a 0. That's going to stay a 1. That's going to become a 0. That's going to be negative 4 plus, no, because I did negative 2 times 0 plus 1. Okay. Negative 2 times 2 is negative 4 plus 3 is negative 1. And then row 3 stays the same. I know, sorry. All the things above it, yeah. Yeah, so I'm using this 1 to knock out everything above it. When I move to the next column, I'm going to use the 1 to knock out the stuff above it. So the pivots are like your tools that you can use to knock out the stuff you don't want. So here, I want to get rid of this 2/3, this negative 2/3 in row 1, right? So row 1 is going to become row 1 plus 2/3 row 3. Yeah. Okay, so row 1 is itself plus 2/3 row 3. So that's going to stay a 1. That's going to stay a 2. Because 2/3 times 0 is still 2/3. Okay, 2/3 times 1 is 2/3 plus negative 2/3 is 0. 2/3 times 2 is 4/3. 4/3 plus negative 4/3 is 0. All the fractions are gone. That's nice. Okay, the other rows don't change. 0, 1, 0, -1, and 0, 0, 1, 2. All right, I have one more thing I need to get rid of, right? I move to the column to the left, move one to the left, and I'm going to use this one here, to knock out the stuff above it. So I need to change row 1. I want to get rid of the 2. I want it to be a 0. So row 1 is going to become row 1 plus a -2, row 2. Last step here. So -2, row 2. -2 times 0 is still 0. Add that to 1, that stays a 1. -2 times 1 is -2, plus 2 is 0. That stays a 0. -2 times -1 is 2, plus 0 is 2. 0, 1, 0, -1, and 0, 0, 1, 2. Yeah, so now if you read this off, translate this to a system of equations, this says 1x plus 0y plus 0z is 2, or x equals 2. 0x plus 1y plus 0z equals -1, or y equals -1. 0x plus 0y plus 1z equals 2. So z equals 2. There's your solutions. Yeah, question? Oh, okay. So forward phase, work left to right, trying to make column by column, every entry underneath the pivot be 0. Once you have that, then you work backwards from right to left, making all the entries above the pivots 0. Yes. Yeah, you should try to turn all the pivots to 1. It'll just make your life easier. In fact, you might. It's okay to do that in the forward phase if you want. You don't have to wait until you're in triangular form. Yeah, it's a long process for something you like already knew how to do, right? But it's really handy when you have like 50 unknowns, right? Because yeah, that happens in a lot of real situations. So, but that's what Wolfram Alpha does. It does a matrix with row reduced echelon form. Oh, nonlinear? Then hang on. All right, so I'm going to have you work through the group activities. It's going to go into a lot more of the details that were in the reading, talking about like free variables and basic variables and that kind of thing. I'll be around to answer individual questions.